You know, we see it every single day, right? That little blue dot just guiding us through the world. But have you ever really stopped to think about what's going on behind the scenes? What makes it work so perfectly? Well, today we're going to pull back the curtain on the incredible tech, the algorithms, the data, the AI that powers your every single journey. So it all starts with that one simple tap. You punch in a destination, you hit go, and boom. In seconds, there's a perfect blue line on your screen. But how? I mean, really, how does it sift through millions of roads, all the intersections, all the real-time traffic jams to find that one perfect route? It seriously feels like magic, doesn't it? But it's not. It's actually this brilliant mix of some heavy-duty computer science and a whole lot of real-world data.
Okay, so the first thing we've got to get our heads around is this. Google Maps doesn't see the world like we do. It's not looking at a picture or a satellite photo. Nope. To the computer, the entire planet is basically just a giant, massive mathematical graph. And that idea, that's the blueprint for everything else.
So to make sense of our messy physical world, the system breaks it down into three really simple parts. Think of it like this. Every single intersection is a node, just a point. The roads that connect those points, those are the edges. And here's the really crucial part. Each of those roads, those edges, has a weight. Now, that weight could be distance or the speed limit, but what really matters is the current travel time. It's the simple, elegant structure that lets a computer actually understand the whole road network. All right, so you've got this giant digital map of the world. Now what? How in the world do you find the absolute best way to get from A to B? Well, this is where the pathfinding algorithms come into play. You can think of them as the digital brain that does all the heavy lifting, sorting through just a mind-boggling number of possibilities. Now, for this job, there are basically two main contenders. First up, you've got something called Dijkstra's algorithm. It's super thorough. I mean, it will find the absolute shortest path by checking every single option branching out from where you are. But can you imagine doing that for the entire planet? It would take forever. And that's exactly why Google uses something called the A-star algorithm. That's A-star. A-star is way smarter. It uses what's called a heuristic, which is really just a fancy word for an educated guess, like the straight line distance to your destination. This helps it prioritize paths that are actually heading in the right direction, so it doesn't waste time checking roads going the wrong way.
And that right there is the key. The A-star algorithm is the secret sauce. It's the reason your route pops up almost instantly. It finds that perfect sweet spot between being accurate and being super fast. And that's what makes navigating the entire globe possible right from your phone. Seriously, without it, you'd probably still be sitting there waiting for it to tell you the first turn. Okay, but a static map is kind of useless in the real world, right? We all know the shortest path is definitely not always the fastest. So this is where the game completely changes. This is where a layer of real-time data and some serious AI makes the map truly come alive.
So where does all this live traffic info even come from? Well, you can think of it like a massive data cocktail. The number one ingredient? Anonymous GPS data from millions and millions of smartphones, including yours probably. When a whole bunch of phones on a highway suddenly slow to a crawl, Google knows, aha, traffic jam. Then you mix in some historical data, because the system knows all about your city's rush hour, and you add a dash of data from government sensors, and of course all those super helpful user reports from Waze and Google Maps itself.
And this is where the AI really shines. See, it's not just showing you the traffic right now, it's actually predicting the future. First, it just sucks in all that data we just talked about. Then its machine learning models get to work, finding patterns. It learns that rain slows things down, or that when a big concert lets out, it's going to cause a jam. And based on all that, it forecasts what traffic is going to be like minutes from now. And then, and here's the cool part, it dynamically updates the weight of those roads on the map, rerouting you in real time to avoid a jam that hasn't even fully formed yet. This whole predictive power thing is what fuels so many of the features we just totally take for granted. Take your ETA, for example. That estimated time of arrival isn't just a simple calculation based on speed limits. No way. It's this super complex calculation that combines the live traffic with what the AI has learned about how people typically drive on that exact stretch of road. And it gets even more clever when it comes to interpreting all that data. The system can actually figure out there's probably been an accident without a single person reporting it. It just sees that a whole bunch of drivers have suddenly slammed on their brakes or are slowing down like crazy in one specific spot, and it puts two and two together. Okay, and here's a really subtle one that I bet you've experienced. You know when it tells you to stay in one of the right two lanes for an upcoming turn? That's not just a guess. That instruction comes from a deep learning model that has analyzed the road's layout and historical patterns of which lanes drivers tend to use to make that turn the most efficiently. I mean, that is just an incredible level of detail. So with all this amazing technology already packed in, you have to ask, where does navigation go from here? Well, as you can probably guess, this whole thing is far from over. The future is all about making the map even more seamless with our actual world. We're already starting to see this with augmented reality navigation, where it puts giant arrows right onto your phone's camera view of the street. That's going to expand with way more detailed 3D models of cities and, of course, direct integration into self-driving cars. But just imagine this, predictive routing that doesn't just tell you the best route to take right now, but actually tells you the best time to leave to avoid a traffic jam that hasn't even happened yet. Wild, right? So the next time you're just following that simple blue line, I want you to remember that it is anything but simple. It's the end result of decades of computer science research. It's powered by a data network that spans the entire globe, and it's being constantly optimized by some of the most advanced predictive AI on the planet. It's this quiet, technological marvel that guides us every single day. And it kind of makes you wonder, right? If this is what it takes to navigate the streets we live on now, what's it going to take to navigate the worlds we haven't even built?